Okay, so now we've looked at fixed speed and any speed. So what happens if we want to look at a particular fan? We want to see why this fan can't get the duty that we've specified, and we think we should be able to get one, but for some reason it isn't coming up. This is where we can make use of the manual option here. So we can say manual, let's say yes there. Now we can drop down to the particular fan that we want to look at. So let's look at a BC219. Now we can, the standard nominal sizes, the nominal size is shown here. So these are the standard sizes. Also the impeller diameters are shown here. So we could drop down to say, I mean we knew we got a 1380 for example. So let's specify 1380 there. We can actually enter a non-standard diameter here. Now we shouldn't really play around too much with these nominal sizes, because these nominal sizes are not necessarily diameters in millimeters. They just happen to be in this particular case. But it's best to work with the desired diameter here when you want to pick a non-standard diameter. So let's just leave that at 1380. We'll leave our percentage size. We've got options for percentage sizes if they are available. And this particular fan, it's only available at 100%. We can also type in a percentage size, and we can type in a percentage width. We'll have a look at the percentage size a bit later. For now we'll leave that as 100, and we'll say find the required speed for the specified duty. So let's have a look, and we found that at 900 RPM, which is exactly the same as what we found out the first time. So let's go back, and let's change now the width to say 80%. Let's have a look, 954 RPM, and we're a little bit further down the curve. So this is just what we found last time. But what if we've already built a fan, and we're looking to match a new duty that we've put in, and it was say we'd made that say 85. Let's have a look. Let's say it was a non-standard size. Let's say it was a 1400 millimeter, and it was 85% width. So let's have a look and see if we can find a speed. So we found a speed of 917 RPM for that particular fan. Now suppose that let's have a look at a small fan, because we've got this maximum and minimum RPM range. Let's have a look at a bigger fan. Let's go for a 1605 nominal diameter at 85% width. Let's see if we can find one. Well, we found one there. It's towards the top of the curve. Let's put the width at 100. Okay, now we're very close to the peak pressure here. So I'm trying to find a fan. Let's jump to an 1855. Okay. So it's telling us that we can't find an 1855 fan that will meet that duty. So what we can do is we can put it in at any speed we feel it might be appropriate. I'll try 750, because the last fan that we looked at was around that speed. But notice now that both these are unchecked. So now we can see that the duty point and square law line are actually getting to the left of peak. So even if we slowed this down, so we could try just slowing it down by trial and error. So it's something like 620 RPM or something like that, isn't it? So, but that is going to be operating on an unstable part of the curve. So we wouldn't recommend that particular fan for this duty. We'd have to use something like inlet vanes or some other control. to get it to operate safely at a higher speed. So that's how we can look around at different sizes and see where the operating point would be. So and we can change the width here again, which would then move that to a better point on the curve, but it's still not very good. The other thing we can do, if we look at the duty requirements, if we have 0 here, 0 here, so there's no, sorry, calculate the density, we've got 20 here, standard density. Okay, so we're doing manual design and plot already here, so it's picked up. We can start with a manual design right from the input screen, so we can say next, or say yes, yes. So now we start off with a BC130 and we must generate a new duty now because there is no duty entered. So if we want to design a full fan based on that speed, we might put that to 1480, say. Then a duty will automatically be generated that falls on the curve and gives us a power. Alternatively, we can say no, and now we don't get a power, but that duty has been remembered on the duty screen. And then we can, there is no kilowatts. Let's say no, let's go back, generate a new duty, say next, yep, next, next. And we can carry on and design that fan and produce all the drawings and necessary information for it. So that covers the manual design option.